This is by far the safest way to deploy upgradable smart contracts and govern the upgradable process through multisig wallets using Gnosis Safe, for example. Hello guys, it's Johnny time and welcome to another smart contract security tutorial. Today I will show you step by step how to safely and in a secure way deploy upgradable smart contracts, including multisig wallets such as Gnosis Safe, and we will use the awesome tool by OpenZeppelin Defender 2.0, especially the deploy module. This is the second video in the Defender 2.0 video tutorial series, the all-in-one platform for secure Web3 development process and lifecycle. In the previous video, I showed you how you can scan your smart contracts for vulnerabilities automatically in every pull request that you make in GitHub using the code module. And today we are going to focus on the deploy module, and I will show you step by step how you can deploy your upgradable contracts in a secure way, in a transparent way, using multisig wallets, not just an EOA account, to make sure that your contracts are safe, secure, and cannot be hacked. So stay tuned, hit the subscribe button, and let's get started. Now, as I mentioned, we're gonna utilize Defender 2.0 by OpenZeppelin, and it's gonna give us a lot of benefits and advantages rather than just deploying it normally, manually using Gnosis Safe. One of the biggest advantages that we're gonna get by using Defender 2.0 by OpenZeppelin is bytecode verification. What does the bytecode verification feature do? How does it work? So imagine that locally you have your smart contract, right? Then you compile it and then you have the bytecode of the smart contract, and eventually this bytecode is going to get deployed to the blockchain. It could be testnet, mainnet, or any other EVM blockchain. Now, the bytecode verification module feature inside the deploy module, what it does is basically hashes the local bytecode that you have in your local machine, in your local environment, and then it takes the bytecode from the blockchain, hash it as well, and compare those hashes. It's amazing because what it does, it basically makes sure that the smart contract that you developed locally is the same smart contract that is actually deployed on the blockchain. Now, what are the advantages of this bytecode verification feature? First, it prevents man-in-the-middle attacks. So if there is someone in your Wi-Fi network and that is overriding your packets and somehow causing you think that you deploy your smart contracts, but he deploys a modified version of the bytecode of the smart contract and then takes control over this on-chain deployed contract, then this is very dangerous attack. And by doing this bytecode verification, we can avoid it. Also, we know that there are some malicious RPCs that might, again, modify and change the bytecode before being deployed to the blockchain. So using this feature that is built in Defender 2.0 deploy module, you can make sure that the local code that you have in your Hardhat or Foundry repository is the same code that actually exists on the blockchain. After going through an audit, you can lock the commit hash of the audited code, and then you can compare the audited smart contracts to the on-chain deployed smart contract, right? So you can make sure that the deployed on-chain contract, it actually matches the audited code that went through an audit in an auditing firm or audit contest or a private auditor if you use also the audit module within the Defender code. But this is only if you choose to go through OpenZeppelin audit at the moment. In the future, there will be more companies and marketplaces added to the audit module. So this is the deploy module, and the first awesome feature is the bytecode verification. Another cool feature while using Defender deploy module is that it's seamlessly, automatically going to integrate with Safe. So you have all the integration between Defender and Safe. You don't have to do many actions through Safe rather than creating your multisig wallet and approving and signing transactions, because all the upgrade process is gonna go through the Defender. And you will have also one place, very user interface friendly, very UX friendly, UI friendly, where you can track all your smart contracts, all your proxies, all your implementation in one place, and control all your deployment process in one place, which is an amazing feature in my opinion. Now, Defender doesn't integrate only with Safe, it also integrates with Etherscan and Blockchain Explorer. So we will set the environment in a moment and we'll see how we set up the environment using Defender. But in the setup process, we will provide API key for Etherscan, and automatically while using Defender deploy module and deploying your smart contracts, it's going to verify the smart contracts in front of the blockchain explorers, if it's Etherscan, Arbitrum Scan, or even testnets like Goerli, Ethereum Blockchain Explorer. So the smart contracts automatically going to be deployed and verified without you doing anything else rather than supplying the API key, which is beautiful. In the future, you won't even have to supply your API key because the integration is going to be even smoother. So as I mentioned in the previous video, they are working constantly of improving it, the UI, UX, adding more features. So I'm super excited about this tool. Now, a bonus that you're going to get while using deploy module is that your deployments are going to be for free. Why? Because once you are using Defender, you already by default going to get relayers. Relayers that OpenZeppelin, it's like EOA accounts that OpenZeppelin creates for you, and they fund them automatically with testnet ETH. So as you can see, I have here two relayers set, one for Sepolia and one for Goerli, and it's already funded with 0.2 ETH. Here I have a bit less because I use the relayer to deploy and play with the tool a little bit. So you can use this relayers to deploy smart contracts for free to all those test networks. So it's another cool feature and bonus that you get while using Deployer. Your deployments in testnets are for free. You don't need to go and run after faucets and getting testnet ETH. Now, the biggest plus that I see here in this Defender module is deterministic contract deployment. Now I'll explain what I mean. Remember the recent hack of Wintermute and Optimism, where Optimism sent tokens, OP tokens, 20 million OP tokens to Wintermute wallet that wasn't set yet. It was a Gnosis Safe that they didn't set, and then an attacker was able in the Optimism blockchain create the same Safe in the same address instead of Wintermute and steal all those 20 million Optimism tokens, which was a catastrophe. Now, using the deploy model, you can make sure that these attacks cannot happen. Why? Because when you deploy your smart contracts using the deploy model, you can make sure that all the contracts has deployed and has the same address in all the EVM blockchains. So how does OpenZeppelin able to use create2 and create the same smart contract address in multiple EVM chains? Let's see. So the way create2 works is that the newly created smart contract address is based on the message sender, the bytecode of the smart contract, and the salt. Now, since the message sender is going to be the same, the bytecode is going to be the same, and they're going to use the same salt, then they're able to make sure that your contract will be deployed in multiple chains, but it will have the exact same address. So you can avoid all this kind of attack of like cross-chain replay attacks where basically you confuse your addresses in between different chains. No more. All your addresses are going to be the same, deterministic in all the EVM chains if you're going to go cross-chain and deploy your protocol in multiple blockchains. So these are so many benefits that you get while using deploy module of OpenZeppelin. Now, as I mentioned in the previous video, currently the Defender 2.0 is in beta phase and it's in waitlist only. So you cannot just sign up and get access to this amazing tool, but you need to fill a form and then OpenZeppelin gradually gonna give you access to the tool. Now, lucky you can use my link in the description below to apply to the waitlist. Then OpenZeppelin will see that you sign up through Johnny Time and it will help you accelerate the process and maybe get access to this amazing tool with all the features like the code module, deploy, and much more that we're gonna cover in later videos. You can get this access to this tool faster. So don't wait, just click the link in the description and fill your information to get access, to be added to the waitlist and get access to this tool. So now I'm going to show you how I'm going to use this Defender new deploy module to deploy first non-upgradable smart contracts. This is going to be much more simpler because we're not going to integrate with Safe and create approval process, but this is the first demo where I'll show you the simple process. Then I will show you another demo of how I do it with upgradable contracts and approve upgrade through Safe and managing all the upgrade through this deploy module. So first, once we go to the deploy module in Defender, we need to set up our environments. As you can see, the production environment and test environment by default are separated. So you won't make mistake as developer and mistakenly deploy your testnet smart contracts to mainnet, or you won't, so basically to avoid mistakes, they create this kind of separation. And now we're gonna do some tests with Goerli testnet. So I'm gonna choose here to set up my test environment. And I'm gonna let's choose two networks. So first I will choose Goerli and Sepolia. So I choose these two testnet networks, and now the next process in this wizard will be to provide the Blockchain Explorer API keys. If I want the Defender to integrate automatically with Etherscan in Goerli and Sepolia, I will have to add the API key so it can integrate with those blockchain explorers. So as you can see, I'm going here to Etherscan, and in API keys, I will be able to see and extract my API keys, copy them and paste them in the setup process in Defender tool. Now, obviously, I'm going to cut this phase, but you just need to go to here to API keys, copy your keys, paste them and click next. All right, so now I set up the API keys. I'm going to click here next, and this is the next process where we're going to deploy our relayers. So we're going to select our relayers, and relayers are simply EOA accounts that Defender is creating for us, and is going to also fund them with Goerli and Sepolia testnet ETH, and these accounts will be used to deploy initially our smart contracts. Now you might ask, wait, but if this relayer account deploying the smart contract, isn't he going to be the owner instead of the multisig or whatever owner that we want? No, because automatically it's just going to deploy the contract and transfer the ownership right after to your EOA account or a Gnosis Safe wallet. So it's okay, it's totally fine. So here I'm gonna choose my relayers for Goerli and Sepolia and click continue. And this is the upgrade approval process. So as I mentioned before, it integrates automatically with Gnosis Safe. Now, since I'm gonna show you now how to deploy non-upgradable smart contracts, I'm not gonna define and configure the approval process, but I will do it later in the second demo where I will show you how to deploy upgradable smart contracts. So I'm just gonna skip this step for now and click here and define this approval process later on. Now the environment is being configured and set up, and once it's ready, let's see how we can deploy smart contracts. Beautiful, you are ready to go, and now as you can see, OpenZeppelin Defender is showing you your team API key and API secret. These are very important because you're going to use it in your Hardhat or Foundry project in order to connect with the Defender from your local environment, because obviously you're going to work locally, create your smart contracts, and by adding those keys of OpenZeppelin Defender, you can make sure that your Hardhat is configured with the Defender tools and all the deployments will work smoothly. Now, currently they don't support Foundry, but again, they're working on it, and Foundry will be supported in the future as well. So what I'm gonna do now is copy my API key and secret to the side. Very important to keep them in a safe place. Now, once I copied my API keys, I'm gonna check mark here, make sure it's checked, and then click Let's Deploy and see how it looks like. Beautiful. This is how the deploy module looks like after we configure it. As you can see, this is the test environment, and we added the networks, Goerli and Sepolia. Now, these are some history of deployments that you can just ignore that I played with the Defender module, deploy module already. And now we'll see how we can actually integrate our project to the Defender tool, to the deploy module, and deploy securely our smart contracts. So I'm assuming that you already have a project, either if it's Hardhat or Foundry, but in our example, I don't have a project, so I'm going to create a new Hardhat project so we can show you how to integrate our Hardhat framework and project and smart contracts to Defender and deploy the smart contract securely. So I'm just gonna create a new folder, And our folder name is going to be Defender Deploy Tutorial. I'm going to change directory to this directory and then install Hardhat and set up a new Hardhat project, right? So we are using npx Hardhat in order to create and set up a new Hardhat project. And we're going to select here new TypeScript project and gonna select all the default options, yes, 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 and move on with the Hardhat new project installation. And inside this newly created folder, Defender Deploy Tutorial, we'll have a new Hardhat project template. Beautiful. I'm going to install some dependencies. I'm gonna run this installation. So as you can see, the installation was completed. And now all the modules, all the libraries are installed, and I'm going to use code dot to open VS Code in this newly created project. Beautiful. So this is our newly created Hardhat project. We have everything here. We're already with the modules installed. And the first thing I want to do is actually to create an N file. So this will be our N file, and here I will define the OpenZeppelin private key and secret. So this is going to be the private key and secret. So it will be Defender key, and this is the key, and it will be also Defender secret, and this will be the secret. Now in my Hardhat config file, I'm going to first import the OpenZeppelin Hardhat upgrades library, and I'm going to do the following things. So first, I'm going to add here the Defender settings to my Hardhat configuration, and the API key will be added to the Hardhat config and being taken from the .env file, because we have .env and we have here to add the .env config, so it will be able to parse and get those Defender key and secret from the .env file. And since we are going to deploy to Goerli networks, I'm gonna add here the Goerli network with the RPC of Anchor and the chain ID, which is 5. Beautiful. Our Hardhat config now looks good. Now, for the sake of the example, I'm going to deploy a simple ERC20 tokens, no upgradable, just a normal ERC token smart contracts. I'm even going to remove here the permit. I'm using the OpenZeppelin wizard, which is, by the way, another amazing tool that allows you to generate smart contracts based on different properties and customize them. And here I'm going to use the most basic ERC20 token without any addition, any extensions, and I'm even not going to mint any tokens. So I'm going to change here this file to non-upgradable token.sol and just rewrite and change everything. Now we are using version 19 and not 20, so I'm going to change the version here to Solidity 0.8.19, and here we have a very simple token. Let's call it non-upgradable, and this will be also the name and NUT, non-upgradable token. Beautiful. Now we have our token and we want to deploy it. So I'm going to go to the script folders, and here we have the default deploy file, which we are not going to use because we need to use some OpenZeppelin built-in functions of the libraries that we just installed, so we can make sure that the deployment go through the Defender module. So the first thing that we need to do is, instead of just importing ethers, we will also import Defender here from the Hardhat library. Now I'm going to remove all this main function, and the first thing I'm going to do is take the constant token, the factory of the content, the factory of the smart contract. So I will do await ethers.get contract factory, and here I'm going to supply the name of the smart contract, which is non-upgradable token. So I'm going to basically create the factory of the smart contract, and then I'm going to do const deployment equals await defender deploy contract to deploy a non-upgradable contract. And I'm going to send here the factory. Obviously, if we had a constructor, we can send the parameters right after with a constructor. And if you want to learn more about those libraries and how they work, you can check out the docs, because everything is in the docs. And here I'm going to do another await deployment dot wait for deployment. So we're going to wait until the deployment is done, the transaction is being processed and added to the blockchain. And once the deployment is done, I will do console.log to print our newly created smart contract address. So it will be contract deployed to, and here we're going to just get the smart contract address. It will be await deployment.get address. So we are using the get address method to get from the deployment object the newly created smart contracts and right away print it. Beautiful. Now that we have our token, we have the deploy script, it's time to deploy our new contract. So since we already have everything set up, the networks, the API keys and everything, the only thing that is left to do is just to do npx hardhat run scripts deploy, and obviously add the network, which is Goerli, because we want to make sure that we deploy it to not to locally, but to the Goerli testnet network. Beautiful. The deployment process succeeded, and this is our address in Goerli blockchain. So we can copy this address and we can already jump through the Defender module, deploy module, refresh the page, and we are supposed already to see our newly deployed smart contract verified through Etherscan. Now it takes few minutes to verify the smart contract, but eventually, as you can see at the beginning, it's submitted, but it's not completed yet. So it's still in deployment and verification process. But here we have the new smart contract. This is the exact same address as you can see that we got over here in our console log. And we can actually, it's not verified yet. We'll have to wait a bit until it's verified, but we can actually open it over here, click here and see it here in the Blockchain Explorer. And as you can see, this is our new token that we just deployed, but it's not verified yet. So we'll have to be patient and wait a little bit. Beautiful, guys. So we waited a few minutes, and as you can see here, it changed from submitted to completed, and also the name of the smart contract changed from just an address to our smart contract name, non-upgradable token. And you can see here that it's verified deployment. And if you click here, you can see that the SHA-256 hash of the artifact localhost bytecode matches the on-chain bytecode, which is the contract that was deployed on Goerli testnet. And if we click over here, in this case, we don't have a proxy, so it's more simple. We'll just see the address of the contract, and it deployed from the real area. We didn't pay any ETH for this deployment. OpenZeppelin sponsored it for us. And we can also see that it's verified automatically in the Blockchain Explorer. So if we click here and open and click in the contract, we can see that it's verified. We can see the name, the compiler version, and all the source code. And now it's time to take a look at some more complex example of deploying an upgradable smart contract. So before actually deploying an upgradable smart contract, we want to make sure that we have a multisig wallet, a safe, Gnosis Safe, that we will use to approve the upgradable processes of the smart contract. So anytime we want to add features, upgrade a contract, add functions, we'll have to approve it through a multisig wallet, which is the safest way these days that most DeFi protocols, all the DeFi protocols are using. So in order to do that, we'll have to create a multisig wallet. So I'm going to go to AppSafe Global and create a new account tutorial. Okay, so we have a new Gnosis Safe. I will click here next, and the first owner is going to be this first account, and I'm gonna add few more owners. So owner number 2 is going to be the second account on this same MetaMask wallet. Obviously, it's not the safest way to do it. It's better to diversify the owners and make sure that it's different owners, but this is just for the sake of the examples. I'm just gonna add all of my MetaMask accounts, the same seed phrase, and it's gonna be 3 owners, 1, 2, and 3, the first 3 accounts. And this is the threshold. How many approvals do we need out of these 3 owners in order to execute a transaction? I'm going to choose 2 out of 3. So in order to execute a transaction and confirm an upgrade, we need 2 out of these 3 accounts to sign a message and approve this transaction execution. And I'm going to click here next. And again, I'm going to use the real layer, and this time it's going to be sponsored by Safe and Goerli itself. And I won't have to pay ETH for this deployment of this new safe. So I'm going to click here next. And now my multisig wallet, my safe, is being created. This is our newly created safe. And now what we need to do, as you can see here in the configuration, we don't have a default upgradable approval process, because if you remember, we skipped this step previously, but now we'll have to configure it in order to upgrade our smart contracts. So I'm going to go to manage, and here to approval processes, and create a new approval process. I will name it and let's call it Johnny's Safe approval, because we're going to use Gnosis Safe in order to approve upgrades, and the network is going to be Goerli. And I'm going to select here Multisig, and now I need to paste the Multisig, the newly created safe wallet that we just created. So I'm going to copy here this address. This is the address of our newly created safe. Remove this. And this is going to be the EOA account, one of the owners of this safe. Now, if you remember, we have 3 owners. So I'm just going to copy the first owner, which is account 1, his address, and paste it over here as the Multisig address owner and save the changes. Perfect. It's created. We go back to the deploy module, and we're going to configure our Goerli network and add here the upgrade approval process, add our Gnosis Safe approval. This is what we just created, and we're going to click here the save button. Beautiful. As you can see now, the approval process was saved, and now we can actually deploy upgradable smart contracts and control the approval process through our safe wallet. So let's create an upgradable smart contract, and let's call it box.sol. And this is going to be our smart contract. As you can see, we import all those upgradable smart contracts from OpenZeppelin contracts upgradable library, like initializable, UUPS upgradable, and ownable upgradable. So these are all the best practices from OpenZeppelin. Let's change it to Solidity 8.19. And this is just a simple smart contract that represents a box with objects. It has a public variable number of objects, an initialize function that initializes the UUPS proxy, and the ownable smart contract sets the number of objects and transfer the ownership to the Multisig wallet. So as you can see, the realer is going to deploy the smart contract right in the initialization process. Right after, it's going to transfer the ownership to the Multisig wallet. We will pass it in the initialize function. And we have here just 2 more functions. Remove one object, which is literally just gonna decrease the number of objects by 1. And we have authorize upgrade, which is only the owner, which is gonna be the safe, because we transfer the ownership to the Multisig Safe wallet. So only the safe can actually approve and authorize upgrades. Now we're going to create another deployment script. We're going to rename the token deployment script to deploy token and create another script. And we just renamed the previous one to deploy token. And this is going to be the TypeScript file that is going to deploy the box upgradable smart contract. And this is going to be our deploy TypeScript file that will deploy the box. It's very similar to the previous deploy token script with some changes. First, again, we import the Defender library from Hardhat, and we get a factory of the box smart contract, not the token this time. And the new thing that we added over here is to get the default approval process. We want to make sure that we have the Gnosis Safe, the approval process defined. We already configured it in the Defender module, so it's supposed to be the address of the Gnosis Safe wallet. If not, we will not allow the deployment and we will just throw a new error, an exception. Here, instead of just using the deploy contract, now we use another function called deploy proxy. And as you can see, we send first the factory of the box smart contract, and here we send the constructor parameters. The first one is the number of objects, the first initial number of objects, which is going to be 5 objects in the box. And the second one is the Multisig, the owner of this box smart contract. And we're going to obviously take it from this default approval process object that is integrated already with our Defender platform. Then again, we will wait for the deployment and just console log the newly deployed contract. Now the deploy script is ready and it's time to deploy our upgradable contract. So we're going to run the same line of code because we just changed the code in the deploy.typescript file. And this time it's supposed to deploy our box smart contract. Beautiful. The deployment succeeded. And here we got the smart contract. Now this time it's probably going to be the proxy smart contract, because this time we deployed a proxy, an upgradable UUPS pattern proxy, and we can head over to the Defender deploy module, refresh the page, and there you go. Here are the newly deployed smart contracts, and as you can see, it's not verified yet. It's submitted. It's going to take a few minutes until it's verified on-chain together with the Blockchain Explorer, so we will wait those few minutes. Yes, our 2 smart contracts, Box and ERC 1967 proxy, were deployed and verified on chain. And we can actually click here the verify deployment and see that it's the same hash again, so we can make sure no one messed up with our bytecode between our localhost to the blockchain. And we can also click here, we can see the proxy address, the current implementation that it's deployed by the relayer, and obviously later on the ownership was transferred to the safe and it's verified on the blockchain. We can also open here the links to the smart contracts, to the blockchain explorer, and we can see that they are verified, both of them, the proxy and the implementation. We just deployed upgradable smart contract and made sure that the Gnosis Safe is actually its owner. Now, to actually validate it, as you can see, I'm here in the proxy smart contract, and when I go to read as proxy, we can see that the owner is actually the newly created safe. So it's the Multisig wallet and not the relayer account. So this is 0xEC, and it's exactly the same address of our safe Multisig wallet. Beautiful. Now let's say that you want to upgrade your smart contracts, maybe to add some functionality to it or change some functionality, and you want to upgrade it. So this is going to be your new smart contract, and we will call it box v2.sol, and it's gonna be we're gonna add some functionalities. So we're gonna include and import the previous box smart contract and inherit from it and just add new function. We had remove object, so here we have add one object, and this is just gonna increment the number of objects by 1. And we also added another function, which is box version, that returns 2. And now we want to submit an upgrade and approve it. So I'm just gonna copy here the deploy script and rename it to upgrade.typescript. And this is gonna be our upgrade script that we will run to upgrade the box from V1 to V2. Now, it's going to be much more simple than the deployment itself, because all we have to do is first take the factory. So const box, and it will be await ethers.get contract factory, get contract factory, and this will be box v2. Now we want to create a new proposal for upgrade. So const proposal, and we're going to use Defender. So await Defender, and we will use the function propose upgrade with approval. So we are proposing an upgrade that should be approved by our approval process, which, if you remember, is the Multisig Safe. Now we need to send some parameters to this function. First, we need to send the address of the smart contract, the proxy contract. So it's going to be this one, the address of the proxy. So this is the first parameter. The second parameter will be the new smart contract, which is box v2. And I'm going to add here another optional parameter, which is redeploy implementation always, because if you already deployed the implementation previously, then it's not going to deploy it again. And as you can see, I did some tests before and I already deployed the box and box v2 smart contracts. So I want to make sure that it will redeploy the implementation of the box v2 and not use the previous implementation. So I'm going to use this option over here. And now we're supposed to be all set. And now I will just do something like this, console.log, and upgrade proposed with URL. And I'm gonna here basically format the URL of this new proposal of Gnosis Safe. So it will be proposal.url. So we're gonna retrieve the URL of the Gnosis Safe from the proposal object that we just created and basically submitted. Now we want to try and run the upgrade script. So I'm gonna change it from deploy to upgrade. And let's run the upgrade process from box v1 to v2. Now, what's going to happen behind the scene is, because we integrated the approval process with Multisig, we deployed an upgrade with our Hardhat project, and then we will have to confirm this upgrade in our Multisig wallet in Safe, because it cannot be approved otherwise, because the Safe is the owner of the proxy. So we will have to go to Safe and approve this upgrade. And as you can see, OpenZeppelin is doing a very easy life for us, because now we can directly copy the URL of the proposal and go directly to Safe and approve it. Or the other option is just go here to the deploy module, refresh the page. And as you can see here, we have a new item in the list. This time it's not deploy but an upgrade, and as you can see, the ERC1967 proxy is asking for an upgrade, and as you can see, the status is pending approval. So we can open this proposal to upgrade, and here you can see all the information about this upgrade, and the approval process is Gnosis Safe approval. We can click here, open in Safe app, and automatically it's gonna open the approval process for us in Safe, smooth integration. And now we just need to approve this upgrade in order to make sure that the contract is upgraded. So I'm gonna click here, confirm. And as you can see, because we defined a threshold of 2 signatures out of 3, we'll have to sign 2 transactions. So I'm gonna click here, sign, and first I'm gonna sign the first transaction from account 1, which is the first owner of this safe. And now we submitted the signature, and as you can see, we have only 1 out of 2 confirmations. So I want to change my MetaMask to account 2. That is going to confirm as well this upgrade. So this is the same second confirmation. So it needs to be also a transaction to execute the actual approval. I'm going to choose Relayer because I like my Goerli ETH. I don't want to spend it. So I'll click here, execute, and let's sign the approval. And we did it. We signed with 2 accounts out of 3. The transaction is now processing using our Relayer in Safe. And once done, we're supposed to see that the upgrade process has completed. And now our proxy actually points to box version 2. And we did it. The transaction submitted and processed. We approved it. And now if we go back to our Defender tool and refresh the page, let's see what we see over here. And we did it, guys. As you can see, the upgrade was executed. You can also click here and see all the details about this upgrade. So we can see that this proxy just upgraded the current implementation, and this is the proposed implementation. This is the new implementation of box version 2. You can also open it in the Blockchain Explorer and make sure that it's the actual implementation and the actual bytecode that we just deployed, the new implementation. You can also click here, view transaction proposal, and the Defender tool is going to show you in the actions module, which we'll cover in future videos, by the way, the whole transaction proposal data and what actually happened. You can see that 2 of the address approved it through the multisig. You can see the new upgrade, the new implementation, that it's a multisig, the 2 out of 3 signatures, very nicely parsed and presented. And imagine now, instead of just being all over the place with your smart contracts, especially when you have a lot of contracts and a lot of blockchains, having everything in one place, seeing everything so clearly, so easily with deterministic addresses in multiple blockchains. This is a game changer for smart contract development in a secure way, in my opinion. Now, another cool thing is that if you go to manage here an address book, you're gonna have your own address book with all your smart contracts. It's gonna be saved, and this is like all in one place to manage your deployments, your smart contracts, development, and security. Later on, you can use this address book to set up monitoring, which we will cover in future tutorials and future videos. It's gonna be amazing because you don't need to just manually add your smart contracts in the different blockchains because you already deployed them in the previous step. So the system remembers your smart contracts, names and addresses and proxies and everything. So it's very easy to set up monitoring and incident response and actions, which is something that we're going to cover in the next video. So if you want to make sure to get it once it's out, hit the subscribe button and the bell notification button. Now, if you want to get access to this amazing tool, which is currently for free, you have to join the waitlist. And lucky you can use the link in the description below to accelerate the process and make sure that OpenZeppelin approves you before other people, because you just sign up through Johnny Time. So definitely click the link in the description below and sign up to the waitlist through Johnny Time. If you enjoyed this video and learned something new, smash the like button and share it with your friends. Thank you so much, and I will see you in the next tutorial. Bye bye.